Okay, so the last lesson for chapter 17 addresses special problems. And really these problems are not that special because they are almost the exact same as those you were practicing recently in chapter 15 with combining different random variables. Let's practice though. Here it says Bob uses 30 grams of sugar in his coffee with a standard deviation of 5 grams. And this is monthly. I didn't write all that in. Monthly. Fred uses 40 grams of sugar in his coffee with a standard deviation of 10 grams, also monthly. Okay. What is the chance that Bob will use more sugar in his coffee in a month than Fred? So before we work this, let's write down what we know. For Bob, we have an expected value of use, we're letting him be X, of 30 grams. His standard deviation, his sugar use is still being represented with random variable X, is 5 grams. For Fred, his expected value, let's let Fred be Y, so expected value of random variable Y being Fred's coffee, or sugar used for his coffee, is 40 grams. And the standard deviation for Fred's sugar use in a month is equal to 10 grams. And just like before, really the trick here is to consider the comparison, just like we did last time, where you say to yourself, okay, what am I looking for? Bob using more than Fred, and then you work to find what the combination would be that matches it. So in other words, Bob more than Fred. Bob greater than Fred. Now let's use X and Y so it looks a little more math alike. X was Bob, greater than Y is Fred. Now putting both variables on the same side of that inequality, let's subtract Y from both sides. We have X subtract Y greater than 0. This is the combination that we've been asked to find the probability of in our question. So let's take a look. Let's find what is the expected value first. Remember, before you can find any probability, you need the expected value, the mean, and you need the standard deviation for this combination. So what is the expected value for X subtract Y? And what is the standard deviation for X subtract Y? Expected value, look up here at the top. I've rewritten these things from chapter 15. Expected value, we see that if you're subtracting, then you go over here and subtract. It matches in the order. So we're going to subtract expected values. In other words, expected value of X subtract expected value of Y. In other words, 30 subtract 40, we have negative 10. For the standard deviation, well, the closest thing we have for a simple combination with standard deviation is the variance formula, where no matter what we have plus or minus, it will be an addition. So let's do that. So we have is equal to the variance of X plus the variance of Y. Now that would have given me the variance, so I need to square root that in order to get the standard deviation. So what we have is the square root of, okay, that's standard deviation for Bob, that 5. So for the variance, that's 5 squared, plus the variance for Y, that would be 10 squared. And that comes out to be a standard deviation of about 11.18. That's the main trick to the problem, just like before. Can you figure out the mean? Can you figure out the standard deviation? Then you go straight to technology. So there's the mean, there's the standard deviation. In technology, what we will do, let me erase some of this problem so there's some more space here for me to sketch this out. In StatCrunch, what we will do is we're going to be looking for the probability of X subtract Y, that's what we were asked about, right, being greater than or equal to 0. So I'm getting that from over here on the left-hand side, bottom of the screen, X subtract Y greater than 0. That's the combination, again, that we have. We're comparing that to greater than or equal to 0. So I'm going to look at this and I'm asking myself, what is this probability? So when you go in the computer, remember you'll just see a plain X for this combination in the computer. And you will use greater than or equal to, you will put a 0. So you'll be looking for this in the computer. And then of course in the computer for your mean, if you use StatCrunch, you'll use -10. Standard deviation, you will use 11.18. And that's using that normal calculator to get that probability, whatever it might be. Okay? Now let's look at one other problem. Here we have some sort of game. Okay? And it says that the outcomes, 10, 20, 50, I guess this is the winnings, we have a certain probability chance of getting that much winning. And then we are told, that we're going to play this game 100 times. And it says, what is the probability that you will win $3,500 if you play 100 times? So the first thing we need, before we can think about any kind of 100 times, the first thing we need would be to figure out the original expected value. If I play just one time, what is my expected value for X? What is that? And what is my standard deviation for X? What is that? Now, because I do not have access to the internet right now, I encourage you all to post answers to these questions for bonus points in our Facebook classroom. So once you figure that out, that may be helpful to your classmates. Remember that the hint to figuring this out, I'm giving you a thought bubble here, the hint is if you like StatCrunch, many of us do, you can go to Calculator and you can use, first you have to put your data in. So I'm going to say first type in data. Type your 2 columns. Second, go to Calculator and choose Custom Calculator. And then from that, it will tell you automatically mean is equal to, that looks bad. Mean is equal to something. Standard deviation is equal to something. And all that you do is extract the values that the computer gives you. There should also be something in Excel that is similar. If you prefer to go to Excel, you would type in your data and have it find the weighted average for you, that's essentially what we're doing for the mean and the standard deviation. So please use technology here, remembering that custom calculator can give you those question marks. So now for the rest of this talk, I'm going to have to find some kind of a symbol to use since I don't know the actual answer here. I've challenged you all to find that answer for us. What I'm going to do, let's say the triangle here. This little triangle will represent whatever the number was, okay? That way when I'm talking, I'm just going to put those values in here. And for the standard deviation, I will represent that with, I don't know, how about a square? S for square. So the number for the standard deviation is a triangle, for the standard deviation is a square, and for expected value, I'm going to represent with a triangle. Okay. So, that was part one of the problem, looking at this main information for a single game and getting the typical expected value and standard deviation. But for 100 games, you may remember that we can find things in sequence. X1 plus X2 plus on and on. We said we would play this game plus 100. Well, 100 times for that series. So we need the expected value for that, and we also need the standard deviation for this. So let's go back now and look at our formulas from chapter 15. Remembering here that whenever we are adding the same event or the same thing occurring over and over, we're going to take m, however many times that occurred, and multiply it by the expected. So whatever you got up here for that triangle, our m is 100. Whatever you got for the triangle, you're going to multiply by 100. Actually, let me do this. So 100 multiplied by that answer from up above, whatever that answer was. Okay, that's what the formula tells us to do. That will give us something. Okay, standard deviation. What we will do is, it says here, square root of m times that standard deviation from above. Okay, so m is 100. We have the square root of 100 multiplied by whatever my standard deviation was. Or we could say 10, right? That's a 10. 10 multiplied by whatever that standard deviation above was. So that was e of x. and this was standard deviation of x. Okay, and we say, okay, what was that? And let's see, it asks for the probability now that you win more than 3,500. So mainly this is about being able to handle multiple steps in the problem, right? Because first you're dealing with individual, then you're dealing with 100 games. Once you have these values to describe what's going on, let's do this. I'll switch colors here. Once you have these values, whatever this number is, all that you need to do is go to StatCrunch or Excel and put that into the system. You know, you have your normal calculator. If you choose StatCrunch, you put in your mean of whatever you just got right here, right? You put in your standard deviation of what you just got right here. And then you're going to say the probability that, and we're going to represent our sequence with just the regular x, since it's like hard encoded into the problem, right? That those x's being added together, that it would be, what did we say? More than. So greater than or equal to 3,500. And the computer will give us an answer, whether Excel or StatCrunch is what you choose to use. Okay, I'm looking forward to seeing you all interact about this on Facebook.